All right, we're going to walk through these molar mass examples. Here's first what I want to remind you of, that molar mass is also called GFM, or gram formula mass, or just formula mass. Okay, so just be aware it can be worded any one of those ways. All right, so let's look. We did these ones in class, but I'm going to go through it. So argon. Argon, if you don't remember the symbol for argon, then you've got to go to table S right here, okay? But I do know the symbol for argon, and it's right here, AR. And on the periodic table, since it's just a single element, it's 39.948 grams per mole. I could, though, round it, and what is appropriate is to round it to the tenths place. If you want to round it to hundredths, that just means more numbers, okay? Totally fine. But what am I going to round this to? Well, look at the next digit. That's a 4. So it's going to be, for argon, 39.9 grams per mole. All right, silicone. If you don't know it, remember, again, you're going to table S, and you're finding the word and looking for the symbol. But it is Si. All right, and that is a metalloid right here. And we have 28.0855. So again, I'm rounding to tenths place. I'm looking at the next digit. So it is going to be 28.1 grams per mole. All right, that's the first two. All right, the next one is F2. That's because fluorine is a diatomic element, okay? So 1 fluorine is 18.9984. So I'm rounding to tenths. Look here. Well, I round up. So this actually becomes 19. And I don't have to write the 0.0 because that does not affect the math at all. So this is the 1 fluorine is 19. But how many fluorines do I have? 2. So I have to do 19 times 2, which is going to be 38 grams per mole. All right, so Br2, same concept, right? Ooh, how did I write it like that? Br2, always a subscript. Okay, so I need to look up Br on the periodic table. Oops, and here we go. We got 79.904. Okay, well, I round to tenths. Look here, so it's going to be 79.9. But remember, that's 1 Br, and I have 2. So I have to take this number times 2, okay? So 9 times 2 is 18, carry the 1, 9, 114, 159, which makes sense. This is about 80. This should be about 160, but a little less grams per mole. Okay, so those are the diatomic. Then we have CaCl2. All right, so I have Ca and Cl. All right, Cl is 35.453, and Ca, all the way on the other side of the periodic table, 40.08. Okay, so we're going to round, Okay, so this is 40.1, and this is 35.5. Then I check for subscripts up here. I have a subscript of 2, no subscript. So this is just 1, so it's going to be 40.1 plus, I have to do 35.5 times 2. And that makes sense because 35 times 2 is 70, right? So 71. And I don't have to put the 0.0. I'm just going to put it here for ease of addition. Look at that. And it is grams per mole. Okay. All right. So the next one is CH4. So I need C and I need H. Okay. Well, H is on this side, so let's grab it first. 1.00794, and then for C, which I can get it from right up here at the key, 12.011. Round to this place, right, tenths place, So this is just 12, and this is just 1. Ugh, that's the easiest math, right? Check subscripts. No subscript for C, so there's just 1 of those. A subscript of 4 for hydrogen. Now I add the 2 together. 16 grams per mole. All right, we got one more, and it's definitely the most complicated one. So I have Ba3PO4 2. All right, so Ba, P, and O. All right, Ba, well, oops, Ba right here. 137.33. Then we have P and O are both on the other side of the periodic table. So P is 30.97376 and O is 15.9994. Now, you do not have to write all of them down like this. I'm doing it just to show you exactly what I'm doing and how I'm getting those numbers. So I round to tenths, round to tenths, round to tenths. So this is going to be 137.3. This is going to be, oh, I have to round this up, so 31, and this is 16. Okay, now I check subscripts. So for BA, it's times 3, okay? So 3 times 3 is 9, 21, carry the 2, 9, 11, carry the 1. Okay, so there's barium, 411.9. Okay, now I need phosphorus. Well, phosphorus has no subscript, but there is inside parentheses, and remember the subscript outside the parentheses gets distributed. So I actually have 2 of those, so that's 62. And then oxygen, I have 4 inside the parentheses, right, times 2, so I actually have 8 of those. So that's 48, 128. I'm just putting the decimal point so I make sure I line them up correctly. So 0.9, 8, 10, 11, carry the 1, 8, 9, 10, carry the 1. Oops, the 9 didn't write. Grams per mole. Whew, okay. Let me just show you one thing that is not a question on this part, but I still want to show you, all right? So if you had a hydrate, so if I just write a random formula, you would do it the same way. I have 1 Ca, I have 2 Cls. Over here though, this coefficient applies to everything inside of here, so I have to distribute it, and then the subscripts matter, right? So I have 6 H's and 3 O's. And then you would do it the same way. Find the atomic mass, the molar mass for calcium, for chlorine, for hydrogen, for oxygen, and then you would add them all up, okay? All right, now we're going to look at these last 3 down here, where it says what is the molar mass of, and aluminum is just a single element. So aluminum is 26.98154, round to tenths. It says round up, so aluminum is 27 grams per mole, okay? Now, the next one I have to do is hydrogen gas, which is H2. So you got to remember the diatomic elements, okay? And sometimes that gets a little tricky because if it says hydrogen gas, that means it's in its natural state, which is diatomic. And if you remember, we rounded 1.00794 to 1. There's 2 of them, so times 2. So it is 2 grams per mole. All right, 1 more left. NH4, NO3. So I have NH, well I have N twice, okay. H we just did, remember it's 1. So let's see, O, do you remember we did this one already? It rounded to 16. So N, we haven't done that one yet, so let's look at it. 14.0067, round to tenths. Well, that's just going to be 14. So I don't have to write the 0.0 because, well, that's just more writing. I don't need to. So I have 1 of them here. That's 14. I have 4 hydrogens, that's 4. I have 1 nitrogen here, that's 14. And I have 3 oxygens, so I gotta do 16 times 3, that's 48. Now I need to add all of those up. So that's 16, that's 20, I'm pretty sure. So that's, yeah, 20, 4, 5, 6, 7, 8. So 80 grams per mole. And that is how you do gram formula mass, molar mass, right? You can call it these things. Molar mass, gram formula mass, or formula mass. And there you go.